Okay, let's look at quantum mechanics. Then we're looking at orthogonality condition of two-way function. This is Jude Comer. Okay. Now, when we say two-way functions are orthogonal, we simply mean that the integral of this two-way function is equals to 0, as we're saying here, that they are integral psi 1 of x, psi 2 of x over some limits from minus infinity to infinity. It must give us 0. So if it does not give you 0, then we say the wave function are not orthogonal to each other. So to explain this further, let's look at an example. Let's look at a worked example. Now, the worked example says that we should show that psi 1 equals to square root of 2 over L sine pi over Lx, and psi 2 equals to square root of 2 over L sine 2 pi over Lx are orthogonal. That means we are bringing this condition of orthogonality here, that our condition for orthogonality must be valid. Now, the next thing, we first of all identify our wave functions. We've been given the wave function psi 1 equals to square root of 2 over L sine pi over L x, and psi 2 equals to square root of 2 over L sine 2 pi over Lx. Now, we recall from our orthogonality condition that the integral from minus infinity to infinity psi 1 of x, psi 2 of x, the x must be equals to 0. Now, for this question now, our limit will simply be the length of the well. Let's say this is a well, this is a potential well. So this will be the length of the well. So we're starting from the length of the well from origin, that is from point 0 to some certain length L. Let's go to the next slide. Now, we say note, the limit of this integration is from 0 to L. Therefore, we show that from our orthogonality condition, we can show that the integral from 0 to L psi 1 of x, psi 2 of x dx must be equals to 0. Now, on fixing our wave function, psi 1 of x and psi 2 of x into this equation here, we're having our equation 1 to be the integral from 0 to L, square root of 2 over L sine pi over Lx, square root of 2 over L sine 2 pi over Lx dx equals to. Now, we see that when we multiply these two constants, we bring out the constant out, square root of 2 over L times square root of 2 over L, we'll have 2 over L. Since the square root sign, we cancel out each other. So that we have 2 over L, sine 0 to L, sine pi over Lx, sine 2 pi over Lx dx. Now, these trigonometric functions here, we cannot multiply them out. So we use a special kind of trig ratio. So we have sine A, sine B equals to cos A minus cos B minus cos A plus cos B divided by 2. This is known as product to sum to difference ratio under trigonometry. Now, if we apply this trigonometric ratio in equation 1, we will have equation 2, where your A becomes pi over L and your B becomes 2 pi over L. And this is what we have in this next equation to be 2 over L, integral from 0 to L, cos pi over L minus 2 pi over L x minus cos pi over L plus 2 pi over L x divided by 2. Now, for our next slide here, we have that when we subtract pi over L from minus 2 pi over L, when we subtract minus 2 pi over L from pi over L, we have minus pi over L. And when we add them together, we have 3 pi over L. That is from here, from here, we have pi over L minus 2 pi over L and pi over L plus 2 pi over L. Now, we see that these two here, we'll cancel these two out. So these two cancels we see that, pardon me, we see that these two, we see that these two, here cancels these two here. So, and also we note cos is known as an even function. Cos is known as an even function. For even functions, the result is always comes out positive. So yeah, the cos of minus pi over Lx is simply the same thing as the cos of pi over Lx. So after integration, on applying our integration, when we integrate cos pi over Lx, we have L over pi sine pi over Lx minus, for this case, we have L over 3 pi sine 3 pi over Lx from the limit of 0 to L. Now we recall that the sine of pi, or we say sine of multiple of pi, like sine of n pi, where n is starts from 0 to infinity, we always give us 0. Take note of that. Sine of multiple of n pi always give us 0. So if we apply it to this integration here, we literally see that this integration will be equals to 0 if we apply that condition here. So here will give us 0. So we can now conclude that the integral from 2 over L, integral from we have 2 over L, integral from 0 to L, sine pi over Lx, sine 2 pi over Lx will give us 0. So the integral, the two-way function psi 1 and psi 2 are said to be orthogonal since their integral equals to 0. So thank you. Don't forget to like, comment, subscribe, and share our video. Thank you.